Hi everyone, this is Byte Relay, and today I'm talking with Pavel Velikhov. He's well-known database scientist and developer. Tell us a few words about himself.
It's a long story. I'm pretty old now. Yeah, I started doing databases when I was an undergrad at GaussDB, somewhere in the 90s. And I think something that really triggered me was back then was Illustra.
Yeah,
That's all the whole thing, right? It's Postgres. Before Postgres went open source, they tried to commercialize Illustra. It's super funny. But then, I went to grad school and I was looking at either doing machine learning or databases when it was the winter of AI. Databases seemed simpler than machine learning and AI at that time.
Does it look like now?
No. I had an impression that, it's very simple to build a database, just code stuff, so no real science.
Just press buttons, the correct order.
But since then, I've been mostly doing database stuff. We started on the XML hype. So in the 2000s, in 99, we opened a company to build a database integration system based on XQuery and XML, and it was the hype of the day.
Are they in production still?
No, it was eventually bought by Oracle, and then they killed it off at some point because they said we don't need an integration system, we need to sell database. But it was a fun journey. We implemented the full XQuery standard and built a nice engine with optimizers. This fun stuff.
I'm aware of current works on JSON pasta and JSON indexing and JSON stuff in modern databases. Is it somehow related to XML developments that you did?
Well, so the good stuff about XML was, it was a full spec. So we had a schema spec, we had a query language specification. It was very complex. That's why it didn't fly, I think, because XML was too complex for what it did in the first place. And then all these things, XML schema was really hard to grasp. XQuery was very hard to learn. So
yeah, XML namespaces. I remember that stuff, and it was like
over-engineered stuff. So I JSON is kind of a better way to do it, a simpler way to do it. But there's still no schema. There's still no standard query language. So it's
do you see it as a binary switch from XML to JSON and YAML and other standards, and that's it? Or do you think that we will observe some new developments in standard data representation?
I have no idea, because it seems like it's up to the industry, and they don't seem to care much.
Just want to imagine how new databases might look like.
Well, there's still, people do use XML quite a lot for kind of document exchange, where you have to specify a real schema and you have to do contracts and you have SOAP and
also juridical stuff is XML, not JSON.
Yeah,
it's not formal enough. If you have a white collar, you have to do XML.
I'm hoping that at some point JSON will take over that space, because XML kind of looks like a dead force.
So you was telling about yourself, and we started XML database. XML was it's most interesting stuff.
So I still, I left US in about 2004, came back to Russia. I still tried to do more XML, so we worked on Sedna XML database, but then it seemed like whole thing was dying. And then I decided to join Mike Stonebreaker with his SciDB initiative. It was a good idea. scientists always complain that they need a good database, and
So you was there when what goes around comes around. This is a prominent art paper in what field? What goes around comes around. I think it's a paper where Stonebreaker says that he's going to work on scientific database.
Oh, maybe. It was 2008, something like that. So the idea was good. Well, scientists need a database when they buy Oracle and they exceed all the limits, and they have to pay huge fees, and the companies just kind of extract money from scientific projects, or like that. So they were always telling database community, please build a database for us, but then finally Mike Stonebreaker decided to do it. But what we did, we made the data model a multidimensional array. We had our own SQL dialect to query that stuff, and when you do a join of arrays, it's a weird thing, so I still don't understand what it means. And
and it's not three-dimensional, it's
multidimensional,
very high dimension. That's always like great when buying the
it's like a tensor database, and in the end, it wasn't going that smoothly. And in the end, the company's still around. There's like a paradigm for it's a company that's commercializing this thing, and but seems like scientists don't really need a database. They don't need transactions. They can just store stuff on S3 and get it. And
if scientists knew what they needed,
they
wouldn't be scientists. We wouldn't call it research. If they knew what to look for.
But it was a great experience working with Mike and his team. He collected a team of professors from different universities, and trying to design the system, so a lot of heated debates over emails, fun stuff. Then I took some time off to do machine learning stuff, and then I came back to do analytical databases with Huawei and TigerGraph and now YDB.
Cool. Very impressive career, and very path with lots of technological pivots. And what would you recommend to some novice hacker? What's the most interesting place to invent? Is it in analytical databases? Is it in transactional or somewhere else?
I think right now.
Sorry, we had some decoration change, slight interruption, but let's go on. So there are a lot of interesting places like analytics, transactions, and maybe something else. What's the area which you would recommend to novice hacker? Where to start a career? What to do now if you want like some data-centric developments?
Well, I would also recommend to try to find the next big thing. Try to do something there, and I think right now the next big thing is graph analytics. And the fun stuff there is that graphs have been around for ages, but applying graph algorithms to data was always a big problem, because you have to extract data from a database and have some graph engine that works somewhere else. You had to build this graph, manage it somehow. So very, very complex. Nobody was doing it. Now graph databases are pretty hot, and people are starting to understand that now I can take my data that has been lying in this database, and with a simple query in graph query language, I can do some fun graph stuff and run a bunch of graph algorithms for analytics, right? So.
Actually, neural networks are graphs too, maybe.
Sure.
In this area, I just wonder when we will see real machine learning in databases. So far, maybe learned indexes and some machine learning in query optimization, but we don't see a lot of machine learning in our area. Why?
Actually, we spent 2 years at Huawei building an intelligent end-to-end optimizer with deep learning, reinforcement learning, all that stuff. And then final conclusion was that it doesn't work and it's not worth trying at this moment. Still, fundamentally for optimizers, it's a bad idea because, you have some analytical guys, they build this really complex query, they got it working fast. And then your optimizer will learn something new and screws up this query, and you can't go back and fix it. It's not a good idea. So you don't really want. Once you have a good plan for a query, you don't want the optimizer to change its mind ever.
So now for a student, if they are choosing their career path, we see that they can choose infrastructure track or machine learning track. Do you think that this station will persist for a long time? Or maybe at some point we will finally mix these two career tracks?
Machine learning is, so you can be like a user of machine learning and build a bunch of trash code in Python notebooks, or you can learn how to implement things like TensorFlow and the actual algorithms efficiently. So that's a different track. So
the infrastructure will be infrastructure.
We need infrastructure for machine learning. I think I also think at some point in database ML is going to be pretty hot because right now the common story is you have your database, you created all these pipelines, flow the data into ETLs, all the things, and then you build a machine learning algorithm and you run it in production. You have to replicate all the flows of the data and then manage it separately as a service and monitor it separately. And so you have to duplicate all this infrastructure just to get the thing working. And we've seen it with TigerGraph. A lot of customers said, why can't I just score the models right in TigerGraph?
Okay, let's move on. Can you recommend to our viewers something, some maybe blog or paper or course or YouTube channel or anything that they can learn something there?
Well, depends on your level, but I would definitely recommend the CMU's core database course to watch it and do the exercises. And they have this, I forget the name of the database. They have
Peloton, I think.
No. They built their own database for students.
So I will find it and put the link. And
so it's a really simple database, and it's incomplete. And you write things like B2E indexes and use some optimizer rules. So in every aspect of the database,
they will end up with Postgres.
No, it's a toy database, but it kind of teaches you.
Postgres was kind of toy database too.
Not quite.
I think Linux at some point was toy operational system, and many technologies were toys.
This is common, and so in OS you have things like Nacho OS, right? Nachos. It's like a special database, a special OS built for students, so they write some small pieces of code, but they understand. They demystifies how the operating system works. So it's the same idea with CMU's database. And then, once you understand the basics, you have to watch all Andy Pavel's videos. They're just awesome. And he's operating this industrial espionage thing. He invites people and they tell all the things they're not supposed to say, like Ruby NDA.
Okay, maybe you want to add something or questions that you would ask yourself in an interview?
Not really, but database turned out for me. I thought initially that it's a simple thing. It's much simpler than machine learning. There's not that much theory, and then as time went by, I saw every different aspect of database evolve. Especially right now, working on optimizer stuff, and it's very exciting. It's very dynamic, so it's really worthwhile.
Cool. Thank you so much for sharing your vision. Thank you.
Thank you.
Thanks for watching. Have a nice day.
Bye bye, guys.